46. Two speakers S1 and S2 operating in phase in the same medium produce the circular wave pattern shown in the diagram below. Okay, so in the diagram we have these wave crests, which are shown in the regular lines, and the wave troughs, which are shown in the dotted lines. And they want to know at which 2 points is constructive interference occurring. So what is constructive interference? Well, when you have two sources of waves, or in this case two speakers, and each one, and this is kind of a general explanation, each one is putting out its own wave, right? So the wave has these points of maximum displacement, which we often call crests and troughs, but it's where the amplitude is at its maximum. So at this point here, we will call this an antinode. Antinode. It's a point of maximum displacement, and this is also an antinode. And the points of zero displacement are called nodes. Nodes. So what happens is when you have two waves that are passing each other, and I won't attempt to draw this, but there are some pretty good visuals available if you search on Google, but when you have two waves that are interacting with one another the way they are in this diagram, and the antinodes meet, whether they be crests or troughs, right, because both are types of antinodes, then the amplitudes add at that point, and that's known as constructive interference. It's the interaction of two wave crests or two wave troughs getting together and adding. And the way you can think about this intuitively is if you're making waves, or you're noticing, or you could do this in the pool, right? You're making waves and someone else is making waves, and if you go in two opposite directions facing each other, when the waves meet and pass each other, it makes a bigger wave in the moment that they're passing. That's constructive interference. That's the amplitudes of two waves adding. And destructive interference, just for completeness, is when you have a crest meeting a trough. They actually cancel out and you get no amplitude. So examples of destructive interference would be B, because B, you have a dotted line, that's a trough, and you also have a crest, and they're intersecting at this point. So the crest and the trough will cancel out, and you'll end up with a node, or a location of destructive interference. So B and C are destructive interference. A and D are constructive interference. You have D of two crests meeting, so it's going to be double the amplitude, and at A you have two troughs meeting, so it's going to be double the amplitude still, but instead of it being in the positive direction, it's going to be in the negative direction, so it's twice as big of a trough, whereas D is twice as big of a crest. So A and D is the best choice, number 2.